Okay, so you've built an AI application. You've got it working. It's pretty impressive, right? It's cool. But how do you actually take it from being a fun demo to a rock-solid, production-grade product that people can really, truly rely on? That's the billion-dollar question, isn't it? Well, the answer lies in being able to debug, test, and actually understand what your AI is doing under the hood. So today, let's dive into the platform that's designed to do exactly that, LangSmith.
Here's what we're going to cover. First, we'll talk about the core problem, why LLMs can be so unreliable. Then, we'll introduce LangSmith as the solution. We'll break down its two killer features. First, how to see everything, and second, the real heart of the platform, how to evaluate everything. And finally, we'll wrap it all up with the key takeaways and the one big thing you've got to keep in mind, the cost.
So here's the fundamental challenge. When you're just using a standard model like GPT, the answers you get can be super generic, you know? They don't have your company's specific knowledge. But even when you add your own data, the models can be, well, inconsistent. They're non-deterministic, which is just a fancy way of saying you can ask the same question twice and get two totally different answers. And for a professional application, that is a massive problem.
And this right here is the question that keeps developers up at night. I mean, if you have a chatbot answering customer questions about your products, you can't have it be mostly right. You need a systematic, repeatable way to make sure that as you add more data and more logic, the answers are still good. How do you build that trust?
This illustrates the risk perfectly. On one run, your app might pull the perfect piece of information and give a fantastic, specific answer. Awesome. But then the very next time, it might just make something up or give a totally generic, unhelpful response. Without a proper system for testing and monitoring, you are essentially flying blind, just hoping for the best, with no way to guarantee quality.
And that is precisely where a tool like LangSmith comes into the picture. It's a platform built from the ground up to solve this exact problem, to help you take your LLM app from a cool prototype to a polished, reliable product that you can actually count on.
So what is it really? Well, put simply, LangSmith is like mission control for your AI app. It gives you all the tools you need to pop the hood, run structured tests, systematically evaluate the quality of your outputs, and keep an eye on performance over time. It's the whole shebang, the full life cycle toolkit.
You know, here's a great way to think about it. If you come from a traditional machine learning background, you've probably used tools like MLflow to track your experiments and models. Well, you can think of LangSmith as serving that same essential role, but it's been custom built for the unique, kind of weird challenges that come with large language models. The whole workflow it creates is this continuous loop, right? You debug problems when they pop up, you create tests to make sure they don't happen again, you evaluate new versions of your app against those tests, and then you monitor everything once it's live in production. It's a cycle that's all about constantly making your application better and more reliable. Okay, so how does it actually work? Well, it all starts with the foundation of everything, observability. I mean, if you can't see what's happening inside your app, you have no chance of fixing it when it breaks. And LangSmith solves this with logging and tracing. Think of a trace like a flight data recorder for your LLM call. Every single time your application talks to a model, LangSmith is there, logging that entire conversation from start to finish. It captures the whole chain of events, basically making the invisible visible. And it captures everything you could possibly want to know. What was the exact input? What was the final output? How long did it take? How many tokens did it cost? Which version of which model did you use? It even shows you all the little steps in between. So if something suddenly takes 10 seconds, you can just drill right down and see exactly where the bottleneck is. Now, tracing is fantastic for debugging one-off problems. But the real game changer, the feature that many would say is the absolute key strength of LangSmith, is its evaluation suite. This is how you go from just fixing single errors to systematically guaranteeing the quality of your entire application.
LangSmith kind of breaks down the messy world of evaluation into two main scenarios. The first is for those times when there isn't one single correct answer, like creative stuff. And the second is for when there absolutely is a right answer, like Q&A over your company's internal docs. Let's look at each one.
So imagine you're generating some marketing copy, or like in our source example, a rap battle. I mean, there's no single correct rap battle about Barbie and Oppenheimer, right? Instead, what you want to do is judge it based on quality. Is it helpful? Is it harmful? Is it creative? Is it cliché? This is where criteria-based evaluation comes in.
And this is where it gets really clever. LangSmith gives you some standard criteria right out of the box, like helpfulness. But the real power is that you can create your own custom criteria. In this case, they added cliché to see if the rap lyrics are any good.
Then, another LLM actually acts as a judge, grading the output against each of these rules and giving you a score. It's an incredibly smart way to quantify quality.
Now, for the second scenario, and honestly, this is the one that's absolutely crucial for most businesses. This is for when you have questions where a correct answer really does exist. To handle this, you create a data set of input questions and their matching ground truth reference answers.
This dataset basically becomes your test suite. It's like a quiz for your AI. You give your application the question from the input column, and then you compare its answer to the reference answer, the answer key that you've already provided. So the most important part is just establishing what correct actually looks like.
And this is the magic trick behind the scenes. How does LangSmith actually compare the two answers? Well, it uses another LLM call, but with some brilliant prompt engineering. It literally tells the evaluation model, you are a teacher grading a quiz. It gives it the student's answer, which is your app's output, and the answer key, your reference answer, and then asks it to grade it correct or incorrect. It's so simple, but it's an incredibly powerful and effective way to automate testing.
So we've seen how LangSmith gives you the power to see everything and evaluate just about anything. But, with any powerful tool, it's really important to understand the full picture, not just the amazing benefits, but the trade-offs that come with it.
So to recap, the benefits are super clear. You get total transparency into what your app is doing. You can build structured, repeatable tests to make sure quality stays high. You can define your own custom rules for what good means to you. And you can monitor performance to catch problems before your users do.
But, and this is a really big but, all of that evaluation, especially that clever teacher grading a quiz part, well, it doesn't happen for free. See, every single evaluation you run is itself a series of new LLM calls, and those calls, they consume tokens, which cost money.
And how much money are we talking about? Well, for the test run in our source material, the cost was exactly this, $1.30.
That's right, $1.30 for a single evaluation run on a tiny dataset with just 4 records. Now just imagine scaling that up to a real test suite with hundreds or even thousands of examples. The cost of evaluation is a very real factor that you absolutely need to plan for. It's the price you pay for quality assurance.
Which really leaves us with this final thought to chew on. We spend so much time talking about bigger models and better algorithms, but maybe, just maybe, the most important innovation in building real-world AI applications won't be the models themselves, but how we develop the discipline and the tools to rigorously and systematically test them.